Assalamualaikum guys. Today we're discussing gradient of the curve, and from that we'll learn how to find equation of tangent and equation of the curve. Okay, here's question number 5, which says find the coordinates of the point at which this curve has a gradient of 12. Okay. Gradient of 12 means that its dy by dx should be equals to 12. So let's find dy by dx and equate it to 12. That's going to be, the 3 is going to come down, multiply with the 2, so 6x, the power will get reduced by 1, 6x square plus 6x. This is the gradient, equate it to 12, bring everything to the same side or divide both sides with 6 as well. To simplify this, I'm going to do that. I'm dividing both sides with 6, so x squared plus x minus 2 is equals to 0. Middle term breaking, x squared plus 2x minus x minus 2 is equals to 0. X is common. X plus 2 is left in the bracket. Negative 1 is common. X plus 2 is left in the bracket equals 0. X plus 2 or x minus 1 equals 0, giving us x equals to 2 or x is equals to 1. Okay. Now we need the entire coordinates, not just the x value. So once you have the values of x, all you need to do is substitute it in the original equation and you would get the corresponding y. So this y would be 2 times 1 cubed plus 3 times 1 squared, that's 5. So the first coordinate that gives a gradient of 12 is 1, 5, and the other one would be minus 2, now I'm substituting minus 4 in place of x, so 2 times minus 4 cubed plus 3 times minus 4 whole squared. Make sure you're writing minus 4 in brackets. This is giving me, oh, I'm sorry, we're supposed to substitute minus 2. Why did I substitute minus 4? Okay, so you substitute minus 2 in the calculator. 2 times minus 2 whole squared, whole cubed, plus 3 times minus 2 whole squared. Okay, this gives negative 4. Okay, the next question is, find the gradient of the curve at the x coordinate 3. Okay, so to find gradient of the curve, we'll need to find dy by dx of this, but before that we'll need to expand it so that we can find its dy by dx conveniently. That's going to be 12x squared plus 3x minus 8x minus 2, which gives 12x squared minus 5x minus 2. Now we're going to derivate it. 24x minus 5 plus 0. I hope you remember this from the last lesson. Okay, and now we need the gradient. So to find the gradient, we're going to replace the x with the given value 3. So 24 times 3 minus 5. It's coming out to be 67. So this gradient that you find is always the gradient of the tangent. So dy by dx gives you an expression for gradient of tangent. For example, this was the curve, let's say, and let's say 3 was here, x is equals to 3 was some point over here. Now, if you draw a tangent, this tangent will have a gradient of 67. So again, dy by dx gives you an expression for gradient of the tangent. And when you plug in x in it, you get the exact value of the slope. Okay, now we need to find the equation of the tangent. For that, we need the gradient, which we already know is 67. Also, we need a point on this tangent. So we know that the x value is 3, but we can quickly find the y value by substituting 3 here. 3 times 3 minus 2, 9, that is 9 minus 2 times 12 plus 1, that's giving me 91. So y is 91 when x is 3. Now from coordinate geometry, you know how to write down the equation of a straight line. You may use point slope form, which is y minus y1 is equals to mx minus x1, or you may use y is equals to mx plus c. I'm using point slope form because it's quicker. Unless the question says use y is equals to mx plus c, I recommend try to wrap up each question as early as possible. So this is a better formula. All right, so we need to find equation of the tangent, and part C says find equation of the normal. Now equation of the normal is simply equation of this line, which is perpendicular to the tangent at the same point 3. So if the gradient of the tangent is 67, then the gradient of the normal is going to be negative reciprocal of that, minus 1 over 67. And we already have the point 3 comma 9 91, which also lies on the normal. So again I'm using point slope form to find equation of the normal. That's going to be y minus 91 is equals to negative 1 over 67 times x minus 3. Okay, so next question is pretty similar, which says find the equation of the tangent and the equation of the normal of this curve at x is equals to 2. Okay, so let's find gradient of the tangent by using dy by dx, which gives us 3x squared plus 6x. And to find the value of m, we're going to substitute the given value of x. So we get 3 times 4 plus 6 times 2, 24. So the gradient is 24. Now equation of the tangent is going to be y equals mx plus c, or y minus y1 is equals to mx minus x1. So we still need a point on this tangent. So we know 2 is a point on the tangent. So when x is 2, just substitute the value of 2 in the equation of the curve. For example, this is the curve. Let's say 2 is here. So we need this complete point. If x is 2, y will be found by substituting 2 in the original equation, 2 cube plus 3 times 2 squared. That would be 8 plus 3 times 4 is 20. So now in point slope form, the equation is going to be y minus y1 is equals to mx minus x1. This is the equation of the tangent. Next part says find equation of the normal. Normal is this line which passes through the same point but is perpendicular to the tangent. So the only thing that will differ would be the value of the slope. It's now going to be negative reciprocal, so negative 1 over 24. And y minus y1 and x minus x1 stays the same. Okay, so the next question is find the coordinates of the point on the curve with this equation where the tangent is parallel to y is equals to minus 2x plus 1. Okay, so there's a curve and there's a tangent at any particular point. We don't know what point is that. And they're asking you that what is this coordinate so that this tangent is parallel to the line y is equals to minus 2x plus 1. Okay. If lines are parallel, then their gradients need to be the same. The gradient here would be y is equals to mx plus c, so minus 2, which means the gradient here will be minus 2. And gradient in terms of derivative is dy by dx. So dy by dx would be equals to minus 2. Okay, so let's derivate the given curve. It's going to be 6x minus 4 plus 0 equated to minus 2. Excuse me. This gives us 2 and this gives us 1 by 3. Okay, so we know the x value of this point 1 by 3. To find the y value, you can plug it in this equation. So y equals 3 times 1/3 squared minus 4 times 1/3 minus 2. What does this give us? 3 times bracket 1 by 3 squared minus 4 times 1 by 3 minus 2 gives us negative 3. So the coordinate is 1 by 3 comma minus 3. So if a tangent is drawn at this point 1 by 3 comma minus 3, then this tangent is parallel to this line. The next question says that, excuse me. Okay, so the next question says that find the equation of the tangent to this curve where it is parallel to the x-axis. Okay, so there's some curve. God knows what it looks like. Maybe something like this since it's quadratic. Find the equation of tangent to the curve where it is parallel to the x-axis. So let's say this is the x-axis. And if the tangent is going to be parallel to the x-axis, it's going to be somewhere over here. Because the x-axis has a gradient 0. So that means this tangent will also need to have a gradient of 0 because it's parallel to the x-axis. So what we'll do, we'll find dy by dx and equate it to 0. Let's start. So that would be 8x minus 5 is equals to 0. That gives us x is equals to 5 by 8. So the value of x here is 5 by 8. Okay, so we need equation of the tangent. Okay, now this is going to be a horizontal line. So its equation is not going to be y is equals to mx plus c, or you could use y is equals to mx plus c because m will be 0. You could definitely use that. Y equals 0x plus c. But it's, in the end, you're going to get an answer like y is equals to a constant because it's a horizontal line. So all we need is to find the value of y here, and then we'll say the equation is y is equals to whatever is this value. Now, how do we find this y? Simply substitute 5 by 8 here. Let's do that. 4 times 5 by 8 squared minus 5 times 5 by 8 plus 1 is giving minus 0.5625 or minus 9 by 16 as a fraction. So y comes out to be minus 9 by 16. So you may use y is equals to mx plus c, then you get minus 9 over 16 is equals to 0 times 5 by 8 plus c. So c comes out to be minus 9 by 16, and then y equals 0x plus c is just y is equals to minus 9 over 16. Or just know that since this is going to be a horizontal line, its equation is going to be y equals something. So this would be the answer. Or you may write the decimal answer, which is minus 0.5625. Okay, so the last question of the day is find the equation of normal to this curve where it is parallel to the y-axis. Okay, now the normal is parallel to the y-axis. If this is the, let's say the normal, I hope you know the relationship between tangent and normal, they're perpendicular to each other. So if this is the normal which is parallel to the y-axis, that means that the gradient, the tangent is going to be parallel to the x-axis. This is going to be the tangent. And then dy by dx would be equals to 0 again. So we'll have to derivate it and equate it to 0. Okay, so let's expand. X square minus 2x plus 1 dy by dx would be, I've used the identity a square minus 2ab plus b square. This becomes 2x minus 2 equated to 0. We get x is equals to 1. Okay. Find the equation of the normal where it is parallel to the y-axis. So let me just try to draw a quadratic curve, because this would be quadratic, and this would be the tangent, and this is the normal they're talking about, which is parallel to the y-axis. Now, since this is a vertical line, its equation is going to be x equals some value. So find the equation of the normal where it is parallel to the y-axis. Yes, so the answer should be x equals 1. We found the answer. The answer here is incorrect. Y is equals to 0 would actually be the equation of the tangent. So had they asked for equation of the tangent, we would have needed to find this equation, and for that you would plug this in and you would get y is equals to 0 for equation of tangent, because this is the tangent, which is a horizontal line. Its value should be y is equals to something, so this would be the tangent equation. And this is the normal. Since it's vertical, its equation is going to be x is equals to something, which is x is equals to 1.